Great. Hey, everybody. My name is Michael Dowd, and this is Anna Dixon, and we're from DataKind. Today, we're going to talk to you about a project we did with an exciting nonprofit organization based out of Haiti. We're calling this Improving Access to Dignified Sanitation in Haiti Through Data. First off, though, I'd just like to intro DataKind to those of you who don't know who we are. DataKind is a nonprofit. We've been around about 8 years or so. Our mission is harnessing the power of data science and AI in the service of humanity. So how do we do that? Our most common way we've done that is through partnering pro bono data scientists with mission-driven organizations to solve challenging problems that hopefully and ultimately make the world a better place. We're also engaged in thought leadership, events, and we're back. And many other things. So we've got a community of about 20,000 members worldwide. We've got 5 chapters. We've done a ton of events, a lot of projects, and worked with over 150 organizations in that time. With our partners and our volunteers, we've been able to deliver over 25 million in pro bono volunteer services to the sector, and we're really excited about that. At the end, we'll also have more information about us, a link to our website, so if you want to get involved, we are doing more projects day by day. So now let's get into the actual project we're talking about. It will happen. There we go. So to ground this at sort of a high level about sort of the big challenge that is trying to be faced here by a lot of organizations. This one organization we worked with, what they're looking at is sanitation. So the world needs better sanitation. 36% of the global population lacks access to a toilet, contributing to health and environmental problems. These are serious things, and we're looking for high-tech and low-tech solutions for how to address this. This issue is particularly evident in Haiti, where the organization we worked with operates. Excellent. So Soil Haiti is this wonderful, amazing organization that operates out of Haiti. They operate throughout the region, and the area we focused with them on was Cap Haitian. So their mission or goal is to increase access to cost-effective household sanitation services in urban communities. They do this with a very low-tech solution that seemingly works great, and it is a container-based toilet system. So essentially, a container-based toilet or a bucket has the special contents in it that help sort of convert the waste as a pre-step. They deliver these buckets to households. Households use them. They collect the waste, swap it out for a clean bucket, transport all of this back to a waste transfer station, and turn this into clean, high-quality, reusable soil or compost. Haiti also faces some some soil degradation issues. So they're addressing a sort of ecosystem here at a large level, which is exciting and fun. Some of the challenges they face, though, are transportation costs and logistics. Transportation is their biggest cost. Having to visit all of these customers, having to transport all of this waste, having to get it all to a depot and then to a waste transfer station, all of this is a big cost. And if they could find ways to reduce the cost, do this more efficiently, they could expand their services, reach more people, and allow this service to be offered to anyone in need or so who desires it. So that's where DataKind stepped in to try to help out. The other challenge they have is that they know there are optimization tools out there. They know UPS, FedEx aren't just sort of looking at a map and making it up day by day. But they didn't have any easy access or affordable access to these tools. So that's where we try to help out as well. I'll give you a little preview of the data situation we're talking about before I hand it off to Anna, who's going to get in the weeds, which is the fun stuff. So first off, we have customer data. So these are households in Cap Haitian. Each blue dot is essentially a household that may have 1 to N buckets, probably no more than 5. We have facility data. This is the depot where the vehicles are traveling to and from. On the left there, you can see vehicles and collectors. Collectors are the actual workers that are visiting the homes, swapping everything out. Vehicles, they've got 3-wheelers. They've got wheelbarrows, which you can see on the lower left, and you can actually see some of the container-based buckets. Other thing I'll call out here is OpenStreetMap was used as our road network. This was identified by Soil Haiti as the sort of most realistic representation of the road network in existence. It also allows us to edit it, which is also super helpful. It's happened again. Okay. So before I hand it off to Anna, I'll just sort of present this challenge as a graph. So this is what we've got. We've got a bunch of different vehicles that have different capacities. Some can hold a bunch of buckets, some can't hold as many buckets. We also have a depot where everybody's leaving from. We have blue dots, which are going to be our customers here, who have demand, you could call it. So they have buckets that need to be picked up and swapped out. And then in between, there are the cost of traveling to and from. So this can be distance, this can be time, this could be actual cost. And the goal is to figure out what is the most efficient number of routes and the sort of route sequence that you visit all your customers, collect all the waste, swap out all the buckets, and get back to the depot to do that in a way that makes the most sense and allows them to expand their service, so on and so forth. So now we can jump into the real interesting stuff here, and I'll pass it off to Anna.
Great. So there we go. To talk about the approach that we took to this challenge. Wow. Here's a tool overview, but the main takeaway from this slide is that our tool can be broken down into 3 major steps. First, you're going to prepare your data. And next, you're going to set up your model and perform the optimization. And finally, you're going to visualize your results. All the while, it's important to remember that one of the criteria for our project is that we needed to build an affordable tool. So we're going to be leveraging a bunch of different open source tools to make this project possible, and I will call them out as we go. So that first step is data preparation. And this step is essentially, our input is going to be your customer GPS coordinates and the expected load, your facility GPS coordinates, so where was that depot located, as well as the OpenStreetMap road network. And the output for this step is going to be clean data for our model, as well as the time and distance matrices. In this step, we use open source routing machine, or OSRM, and that's sort of the heavy lifter, and it's an open source tool. And it's going to calculate the time and distances between the nodes as seen on the OpenStreetMap road network. Furthermore, our team developed custom Python bindings to the OSRM engine, and this resulted in a 10x speed up for our system. So to the data preparation really just sets up our model for optimization. So when you have your input, we have those GPS coordinates shown by the blue dots, and we have expected loads. Those are the bold numbers beside them, as well as the depot, and then our OpenStreetMap road network. And really what the input is, it's a graph with no edges. And so the first thing that we're going to do, is that we're going to clean the data. So you'll note that one of the customer nodes is out in the ocean. That's no good. It's going to break our model if we send it in this way. So we simply remove the nodes that are problematic and report them to the customers, the partners, for further inspection. And then we're going to use OSRM to find the most efficient routes between all the customer nodes and fill in those graphs edges, or either the time or the distance between each, depending on which one you're planning to optimize. An important note is that OSRM supports heterogeneous vehicles. So soils operations in particular use both three-wheelers and wheelbarrows. The three-wheelers are fast and the ones most often used, but they also use these wheelbarrows in the dense urban populations that aren't as easily accessible by the road. And so you can develop these custom vehicle profiles for OSRM to best represent the vehicles that you're using. Some of the example parameters that you can customize are the speeds that these vehicles will travel on different roads, whether or not they are able to perform U-turns in the middle of a road, and also what types of roads are permissible. So that wheelbarrow can go on the pedestrian and bike paths where the three-wheelers can't. This was an interesting challenge that we faced when we first produced this map of our optimized route to the partner. You can see that the route goes clear down to the southwest and then sort of loops back up and collects these different customers, and then it has to go back down and back out again. When Soil had local knowledge that we didn't, and they said, we use this bridge where the arrow is pointing. And we struggled to actually get the tool to use that bridge. And that was because at the end of the day, the bridge was misrepresented in OpenStreetMaps. And it wasn't even usable for vehicle routing. But because this is open data, Soil, our partner, is able to go in and immediately edit that data and fix it. So that's kind of a cool, component of the tool that we built, that's a possibility. Okay, great. Now we've prepared our data. The next step is to perform the modeling and optimization. The input into the step is going to be your time and distance matrices that we've just computed, as well as vehicle data. So the number and types of the different vehicles, as well as the capacity of each. And the output for this step is going to be the list of routes with your optimized order of customer visits. We use Google OR Tools, another open source tool, to optimize the order of customer visits for us. So it solves the optimization problem. But we developed the code to prepare the data to the format that's required by OR Tools. Google OR Tools is optimizing a problem that we call the capacitative vehicle routing problem. So we have that graph from before. I really like graphs. and we have an example of a vehicle. So here we're saying that we're going to travel this graph with this three-wheeler, and the three-wheeler has a capacity of 20 buckets. And I don't know if you can see it, but the different customers have buckets that you need to pick up of 9, 6, 7, and 8. Those are our loads. So at most, this vehicle can pick up 2 of those customers on a single route before it needs to unload. So it's going to return to that depot and unload the vehicle and then repeat. So the optimization, as explained in this graph, is that Google Tools is going to find the minimum sum of the edges such that every node needed to be visited, and the sum of the loads didn't exceed the vehicle capacity. And for this example, it found these 2 routes as shown. Finally, we've optimized our routes, and we need to visualize our results. So we take that optimized list of routes, as well as the OpenStreetMap road network. We put it into this final phase, and we produce HTML maps, as well as a textual solution. First, it's important to note that the output from our previous step is simply a list of the GPS coordinates that it's going to visit. So we need to call on OSRM again to find the routes. So once we have put together the routes, we then use a different open source library called Folium that allowed us to quickly and easily visualize the results. The first map that we built was the master map, and this contains all of the routes. This is great for the people in the Soil office, so they can quickly look and assign drivers to our different routes. And the different colors represent different geographic regions that Soil had already designated. Furthermore, we also made zone-level maps, and so these are just those smaller geographic regions, usually about 4 or so routes containing about 200 customers. But these were put onto the driver's mobile devices, so they could take it out with them into the field and follow them there. And you can see, because we've built these nice HTML maps, they can zoom in and out, and the number on the node markers is just the order in which the customers are to be picked up. Some conclusions for the work is that Soil is currently testing the tool and routes with their collectors. When they came to us, they said that with the data, they currently had to do it in 38 routes, whereas our tool proposes that it can do it in 33. It is now, this is also an important factor, is that it's now easier and faster for them to remove customers. So before, they were manually removing and adding customers and trying to figure out which route do we give them to, which driver, but now it's that we've automated that process for them. This work wouldn't be possible without all the open source tools that we've cited and others that I may not have, but also the volunteers that worked on the team to put it together. They're amazing, and they're listed here. And the project was supported by the 11th Hour Project. Like any good perfectionist, we have lots of next steps. First, we would like to generalize the tool a bit. So we want to be able to support any OpenStreetMap region and vehicle profile. Right now, they're hard-coded. We would also like to Be able to support additional models. So maybe we talked about this being the capacitated vehicle routing problem, but hopefully we can put in the models with time windows and without vehicle capacities. There's a few more things we'd like to do, some scale testing, dynamic vehicle profile selection, and optimized depot placement. I'm happy to go into these further if you find us afterward. Finally, DataKind is exploring the idea of releasing this as a generalized open source tool. So if you thought this sounded really great, hopefully you can have access to it soon for your own use case. If using data science for social good is something that sounds really exciting to you, I really hope that you consider getting involved. Here's our contact information. I think that's it. Thank you.
Thank you.